Good day, everyone. Here's another question on trigonometric identities. If sine A equals 1 over root 10, sine B equals 1 over root 5, we are asked to show that A plus B equals to 45 degrees. Okay, now this is it. A and B, the two angles, will be acute angle in this case. Now, for us to have A plus B to be equals to 45, so it means the two angles must be what? Acute angle. That is, the sum of A and B will be equals to 45 degrees. Okay, now the first thing we need to do is to first write the sum to product formula for the sine of a sum of two angles. That is, now we know that using sum to product formula for sine, okay, for sine. So we know that sine A plus B is equals to sine A, okay, cos B plus sine B cos A. So this is the sum to product formula for sine. Now let's not forget that we are given sine A equals 1 over root 10, sine B equals to 1 over root 5. But here we don't have cos B and cos A. So that means we would need to find cos A and cos B. Alright, to be able to find cos A and cos B, okay, so remember, like I said, we are given sine A, which is equals to 1 over root 10, okay, then sine B, which is equals to 1 over root 5. But we do not have the value for cos A. Alright, we do not have the value for cos A and the value for cos B. We do not have the value for both. Okay, so to be able to find the values for both, now we have it here that sine A plus B is equals to sine A cos B plus sine B cos A, and we know the value for sine A, which is 1 over root 10, the value for sine B, which is what? 1 over root 5, but we don't have the values for cos A and cos B. So what we need to do now is to use we should use what we call the Pythagorean identity. That is for cosine and sine. All right, so we can now use the Pythagorean identity. You know, we have many Pythagorean identities, so we can now use the Pythagorean identity. So we know that cos² theta, okay, let's say the angle is theta, okay, plus sin² theta, that equals to 1. Now, because we want to obtain the value for cos A, so we can write cos² A plus sin² A equals to 1. Now we know what sine A is, which is 1 over root 10. So we then have cos² A equals to 1 minus sin² A. So which means cos² A will be equals to 1 minus. Now we know that sine A is 1 over root 10. Then we raise that to the power of 2. And we know that the square of 1 over root 10, that will be 1 over 10. Alright, so in this case, so we have cos² A equals to 1 minus 1 over 10. Okay, now let's simplify the right hand side. So we know that cos² A will be equals to, this will be 10 minus 1, that's 9. So we have 9 over what? Over 10. So here we need to take the square root, okay? So when we take the square root of cos² A and that of 9 over 10, okay? So we're going to have cos A to be equals to plus or minus root 10. So this is cos A, okay? All right, then also, we also need cos B. We need to find the value for cos B. So for cos B, so we are using cos² B plus sin² B, and that will be equals to 1. So because we want to obtain the value for cos B, so we have cos² B to be equals to 1 minus sin² B. So that this will be 1 minus, what is what is sine B? 1 over root 5. So we have 1 over root 5, then raised to the power of what? 2. Because we have sine squared B. Okay, so that this will be cos squared B equals to 1 minus 1 over 5. Now, if we simplify this, we're going to have cos squared B to be equals to 4 over 5. Okay, now, also to obtain the value for cos B, now we take the square root. So if you take the square root of both sides, okay, so this becomes plus or minus the square root of 4 over 5. This will be cos B equals to plus or minus 2 over what? Root 5. So now, yes, we have what we call quadratic roots in this case. But what is important is, because we already know that A and B, the two angles, are acute angle. So which means the fact that we have plus or minus 3 over root 10 and plus or minus 2 over root 5 in this case, we're going to have 4 combinations. That means 4 values, okay? That means there will be 4 possible values in this case. What I mean 4 possible values, that is two possible values for cos A and 2 possible values for what? Cos B. So that means we'll have 4 combinations. But because the two angles must be acute angle, so which means we are going to consider the fact that for the two angles to be acute angle. Now, since the two angles, okay, let me put it this way, the two angles can be considered to be possibly acute angles, all right? So which means we can then have sine A plus B, which equals to, we know that to be sine A cos B plus sine B cos A, okay? So which means we're going to substitute the values for, that is, we substitute the values for, that's the values for cos A, that's the positive values for cos A, the positive values for cos A and B, cos B, okay, into the identity above. So I'm talking about this identity. So we can then have our sine A plus B to be equals to, now we know sine A is 1 over root 10 multiplied by, we have cos B is 2 over root 5, then plus, then also we have sine B is 1 over root 5 multiplied by cos A is 3 over root 10. Okay, so now multiplying this, so we know that sine A plus B, that's our left hand side. So 2 times 1, that will be 2. Then root 5 times root 10, that will be root 50 plus 1 times 3, that will be 3. Then root 5 times root 10, that will be root 50. Now, same denominator, so we can add the numerator. So we have root 50 as a common denominator. So we then have 2 plus 3, and that's what? 5 over root 50. Now we know that root 50, okay, is the same as root 25 times 2. And we know that root 25 multiplied by root 2 is the same as root 50. So that means this will be 5 root 2. So which means we can then have our sine A plus B, okay, to be equals to 5 over 5 root 2. Okay, 5 over 5 root 2, because we have here that root 50 equals to what? 5 root 2. So 5 will cancel 5. Okay, so we then have sine A plus B to be equals to 1 over root 2. Yeah, so we're almost there. All right, so now we have sine A plus B equals to 1 over root 2. So all we need to do here is what? Is to take the inverse sine of 1 over root 2, and that will give us the value we're looking for. Now, let's recall, we know that from similar triangles, sine 45 degrees is radical 2 over 2, or root 2 over 2, okay? And that is because when we have 1 over root 2, and we rationalize 1 over root 2, of course, we're going to get root 2 over 2. So let's not forget now, let's recall. Okay, we know that sine 45 degrees is 1 over root 2 or root 2 over 2. Okay, or root 2 over 2, which is the same thing as 0.7071. So which means which means A plus B will be equals to the inverse sine of 1 over root 2. And here we know that sine 45 degrees is 1 over root 2. So which means the inverse sine of 1 over root 2 is 45 degrees. So we just proved that the sum of the two acute angles A and B is equals to 45 degrees. The noblest pleasure is the joy of understanding. Bye-bye.